Okay, guys, so this is chapter 4, section 2, using the laws of exponents. And we're actually going to end up using these laws in order to multiply a polynomial by a monomial. So let's review some of these laws of exponents. When I multiply like bases, I add the exponents. So this becomes a to the m plus n. And an example of that would be if I took x squared times x cubed, I would end up with x to the fifth. Pretty simple. Okay. Here, I'm taking a product and raising it to a power or an exponent. So I'm going to take this exponent m and I'm going to apply it to whatever is inside my parentheses. So this becomes a to the m, b to the m. Okay, and this will be better explained down here when we look at some of the problems. This rule is taking a power and raising it to another power, and here is where we multiply the exponents. So let's take a look at a few of our problems. We have 2x to the fourth times x cubed. Well, this is this rule here, rule number 1. I'm simply going to add my exponents, 2x to the seventh. Here, 3x times 4x to the fifth. I'm going to multiply my numbers first. That gives me a 12. And then I'm taking x to the first times x to the fifth, which gives me x to the sixth. Here I have my power rule. This exponent 3 is going to be applied to the 2 and to the a squared. 2 cubed times a to the sixth, which ends up being 8a to the sixth. Okay, another similar problem. This outer 2 exponent is going to be applied to the a and to the b to the fourth. So I get a squared b to the eighth. Power to a power. M to the 2r, because power to a power, we multiply those exponents. Okay, I'm getting a little challenging here now. C to the x times c to the 5 minus x means c to the x plus 5 minus x, because we add the exponents. Well, what happens is these x's end up canceling out, and I end up with just c to the fifth. Okay, 5x times 3x squared times 4x to the fourth. I'm going to multiply my coefficients. 4 times 3 is 12, and 12 times 5 is 60. That gives me that. Got x times x squared times x to the fourth. I add those exponents, so 4, 5, 6, 7, 60, x to the seventh. Okay. Negative r squared times r to the fourth. This is order of operations. Okay, this negative is not going to make this a positive r squared. This is the opposite of r squared. So my answer is still going to be a negative, because I'm taking negative times a positive. I'm going to add my exponents, and I get negative r to the sixth. Okay. This outer exponent is being applied to the 3, to the x squared, to the y, and to the z cubed. So 3 squared, x squared raised to the second power is x to the fourth. Y raised to the second power is y squared. Z cubed raised to the second power is z to the sixth. My final answer is 9, x to the fourth, y squared, z to the sixth. Okay, so here is what our objective was, to take a polynomial and be able to multiply it by a monomial. So here we use the distributive property. Okay, 6y squared times y squared will give me 6y to the fourth. 6y squared times y will give me 6y cubed. And 6y squared times negative 2 will give me negative 12y squared. Okay, number 11, where we have to mind our p's and q's. Okay, I'm taking this outer monomial and distributing it throughout the 3 terms of the polynomial. 2pq times p squared is 2p cubed q. to p cubed q. Now I'm taking this outer monomial and multiplying it by negative 3p cubed. I get a negative 6 p squared q squared. P squared q squared. And then finally to the last term, 2 times 2 is 4. There's no p in here, so it's just p. Q times q squared gives me q cubed. Okay, now we've got a juicy one. So let's see how this works. I have a to the x minus 4 times the quantity of a to the x plus 2 raised to the second power. So I have to deal with this part first. Okay? So this is power to a power. So I have to multiply this times this. So I have a to the 2x plus 4. And I am multiplying that by a to the x minus 4. Now I have like bases, so I'm going to add my exponents. So I have a to the x minus 4 plus 2x plus 4. My 4's end up canceling, and I end up with a to the 3x as my final answer.